research has been conducted regarding performance measures on freeway operations, there is a lack of generally accepted methodology or criteria for evaluating signalized corridor performance. This presentation focuses on using vehicles' trajectories for evaluating corridor signal timing coordination. I'd like to invite Jeff Jenk to provide an overview of this item.
Great, thank you, Mr. Chair, for the intro. I would like to recognize that our speaker, Dr. Tian, is the inventor of the TransSync tool that we have recently introduced in the TSOP program. And Dr. Tian is extremely passionate in the field of traffic signal operations. This is evident in his national research leadership. He is also renowned for his uncanny ability in working with the practitioners to develop the real world solutions. And this presentation you're about to hear is aligned with the MAC's objective to improve the regional practice in the traffic signal operations. Without further ado, it's my great pleasure to introduce Dr. Tian for the presentation. Dr. Tian.
Okay, thank you, Jeff. Thank you, Mr. Chair, and all the committee members. It's really my great pleasure to have this opportunity to talk to you some of the work that we have done. My understanding is that not everybody in this group actually work on signal timing. And therefore, you may not fully understand some of the technical details, but I'm still hoping, at least you will get the major ideas, what is behind trajectory-based performance. Next slide, please. Yeah, this is kind of a outline what I'm going to talk about. If I don't know if everybody is aware of or have heard of what is called ATSPM, Automated Traffic Signal Performance Measures. So I'm going to talk a little bit about the two types of such systems. One is called detector phase-based. So this is what the FHWA is currently advocating. And then the second is vehicle trajectory-based. And then my second focus is to talk about, based on the vehicle trajectories, so how can we come up with some kind of performance measures, which, I call it quality of signal timing index. And how can we use that in practice to evaluate the signal timing projects? And then third part is kind of a case. I want to show you a case to kind of indicate the correlation between a detector phase-based versus a trajectory-based. So before move on, I want to just throw out 3 questions. While you are listening to my presentation, I want to keep in mind these 3 questions. And by the end, hopefully you will get some opinions about how to answer these 3 questions. So the first question is, ATSPM, this is currently, as I said, FHWA is advocating. Many agencies has implemented. So do you believe ATSPM can automatically provide signal timing plans, timing solutions, so that once you have it, you no longer need to do signal retiming? So this is the first question. The second question is, what is lacking or missing with the current practice on evaluating signal retiming projects? So what is really the current practice? It's before-after studies, right? So that's very normal. We do before-after studies. So what is missing or lacking in this current practice? So that's the second question. The third question is, we have different performance measures either generated from ATSPM, detector event-based versus trajectory-based. How can we really adopt them into the current practice? So just keep in mind these 3 questions as you hear my talk. Next, please. So this is the, I call it detector phase, signal phase-based ATSPM. So this is what the FHWA is currently advocating. And what you are seeing here is it's showing at a particular intersection approach and at different cycles, how the vehicles arrived. You can see that those dense black dots, those are vehicle arrivals. And you can see the two parts, right? When it's a bad offset, the most vehicles arrive when it's red. And then once you change the offset, most vehicles arrive on green. So this is a percent arrival on red, percent arrival on green or green. So this is one of the major measures reported from ATSPM. Next, please. But you need to recognize this is only based on one intersection approach. So how can we evaluate the entire corridor as a whole? Research has attempted to come up with a criteria. So this is one of the research. I'm not going to get into details. Basically, you look at all the intersections, you look at the percent arrival on green, also the volume to capacity ratio. And so what you gave a letter grade, A, B, C, D, or F, and then you pick the worst as an indicator for the entire corridor. So this is just a research idea. I did ask in the IT community, which agency has implemented something like this. So no agency really responded. So so this is something, like I said, it's just a research idea. Next, please. Next. Now I'm going to focus on the trajectory-based, different from the event-based. So trajectory-based is really, we're talking about floating car type of travel runs. Currently, like I said, we do before-after studies. So you go there to drive, you collect the before and after travel runs, and then you report the travel time and delay. Now, trajectory-based performance, do we have something in place? Some agencies actually are using with a certain kind of measures. So as far as I know, Orange County in California is the only agency that has something similar in place. So this is called a Corridor Synchronization Performance Index. So it's a kind of score-based, based on the stop and the speed, you give a score. So I'm going to show you later in more detail about this. And then we did some enhancement on our research group. I'm also going to show you, how does that look like? So based on trajectories, how the signal corridor synchronization performance index looks like. Next, please. Yeah, just click that. You see this? Okay, yeah, here. Stop here. So this is what the Orange County has used, how their methodology works. You can see there's a speed, average speed. There's a green per red. Red is a stop. Green, is non-stop. So basically, you report if I have 10 signals, I made 2 stops. So that green to red is going to be 8 to 2. So 8 green versus 2 red. And then 30 is a stop per mile. So each measure, there's a score. On the right is the corresponding score. And then you add all these 3 scores, you come up with a total score. So click, just click. Now this is their tier. You can see tier 1, if you got a total score above 80, that means this is a good signal coordination. So probably you shouldn't spend money on this corridor. And then tier 2, tier 3, you can see it based on different scores. So it's a score based. Again, you think about it. Earlier, I asked you, why do we need such a performance index? The before after study, why that is not enough. Before after study, yes, you can show the after is better than before, but it doesn't really give you an indication. Can we still do better? If we do the best, what performance can we achieve? So this is why we need such a performance index. Next, please. I just want to show you, these are two trajectories. And you can see this corridor has 11 intersections. So there are two trajectories. Hopefully everybody can read the trajectories. You can see the slope is the speed and the stop is the horizontally. If there's horizontal line, that's a stop. The stop can be long, can be short, right? Click. Based on these trajectories, so this is Orange County's methodology. It gives you a score, like the one on the top, which is the line on the right, you get 92. And the other one, you get 65. So 92 is the tier 1. So that means that trajectory number 1 is actually very good. The second one is not so good. You can tell, right? The travel time is long, number of stops is more, and the stop is also long. Now, what's the next? I'm going to talk about our enhancement. So this methodology, in general, is a good idea, but there's certain things that is missing. For example, you only know the speed, but what is the speed limit for you to achieve this speed? And the stop, yes, it's a stop, but the stop can be very long, can be very short. So we cannot treat a long stop and short stop the same way, right? So these are the sort of enhancement that we did. So next, the same trajectory, click, and this is the UNR, the research we did. Now you can see there's a speed, of course, and percent speed. That is a percent speed of the free flow speed or speed limit. Then there's a speed score, number of stops, 3, and then we convert that into standard stop, 1.7. That means 3 stop, actually they are pretty short. And then percent stop, and then you come up another score combining both. And then there are further adjustments. For example, what cycle did you use to achieve this performance? If you use the very long cycle, we will deduct some points from that. And also the final score is based on 100 scale. So it's a lot easier for people to interpret. So you got 95, that's A. You got 70, that's C. So this is the UNR's performance index. Next. Now, how can we get these trajectories? Of course, you can go there to collect them manually. Jeff mentioned the next fiscal year, and all the TSOP project requires TransSync, using TransSync to collect these trajectories. But if you go there to collect these trajectories manually, it's time consuming, right? It's the number of samples is still limited. So how can we get many trajectories automatically from a third party data sources? So this is what we have developed. This program is called STEP, Systematic Trajectory Extraction Program. It works with the visual. So I know in the region you have visual data. So visual provides raw trip data, and this program will extract the trajectories based on the corridor you define, and also the time period you define, AM, midday, PM. Next, please. This is just one example to show you. This is a corridor in Reno, Kiski Lane. This is the midday and running between 10 a.m. to 12:30 p.m. And these trajectories were automatically extracted from visual data. And you can see we have the time-space diagram. And the trajectories, after we extract these trajectories, it's going to be in the same format that you can easily import into TransSync. And you can see these trajectories aligned very well with the time-space diagram. So everything is very clear, why you made a stop, why you didn't make a stop. So with the time-space diagram at the background and the trajectory in the front, and you can clearly see what's happening. Next. Now, what is the performance based on this? First, the Orange County Performance Index. as you can see, is showing, just click, it's going to highlight the total score. The two directions, you can see 102, 106, average 103, which is way above 80. So that's excellent. The greens per red ratio, that's 5.5. I highlight this one because this is a lot easier for you to understand. Greens per red, every stop, how many greens you passed. As a comparison, Orange County, like I said, Orange County, California, they do this kind of performance report every 2 years. So their region, on average, this number, greens per red, is about 2. So 2, in my opinion, is not a very, very good performance. And so, I just want to kind of have a sense to compare with their numbers to see where we are. So that's the Orange County's performance index. Next. And click again. Yeah. So here, this is UNRs. As I said, the score is based on a 100 scale now. You can see it on average, both directions. We got 91, which is A minus. And then for northbound is 89, it's the B plus. Southbound is 94, is A. Okay. At the beginning, you also see the number of trajectories, total of 43, northbound 29, southbound 14. So this is based on, I think, 2 weeks of data for this particular corridor. Next, please. Now, this is another location. Apparently, for this location, we got a lot more trajectories. And this, the raw data is about 3 seconds per location. Too many, it's hard to see whether where it matched the timing, where it didn't match the timing. Click next. Let's just look at the perform. Oh, I didn't have a performance. So anyway, so that just gave you an idea. This program we have, we can automatically extract these trajectories. What I want to present next is a case study. I want to take a look to see the detector event-based measures, how it is correlated with the trajectory-based. I select this segment in Las Vegas because Las Vegas, they implemented the ATS-PM. For this particular segment, and they were able to report percent arrival on red. As you can see here, I marked the 2 directions at each signal. Okay, where if you don't see the numbers, that means the data is not available. Detector either was not working or they didn't implement anything to collect such data. So the blue going westbound. So the green, the arrow going eastbound. I just arbitrarily marked anything above 50%. So here we're looking at the percent arrival on red. What percent of vehicles arrived when it's red? Okay, I just marked everything above 50% as red. So means probably it's not so good. Okay, so if it's below 50, then it's I didn't mark anything. It's just black. Next, please. Now you can see on this figure, on the right is the same number. On the left is the time space diagram with the trajectories. So I didn't put really the timing information there. It's just the trajectories. And then you look at all these trajectories. Let's just look at the westbound. Okay, let's just focus on the westbound. Westbound is on the right side is the blue arrows. On the left side is going from the bottom to the top. And you can see the first one, 59% at Jones Boulevard. It's because every vehicle stopped. So that matched pretty well, the trajectory versus detector-based measures. And then 53% at Torrey Pines. Yes, every vehicle, most vehicles stopped. That's why that percent arrival on red is high. Although the stop is much shorter than at Jones. And then look at the 51% at the Buffalo Drive. That also matched very well, right? 51% person arrival on red because every vehicle stopped there. The place that didn't match is where you see that 30% Tenaya Way, 30%, although every vehicle stopped there. However, the detector-based event says the person arrival actually, person arrival on red is not that bad. So why is that? You know, by just looking at this in the trajectory or the person arrival on red, it's hard to really hard to tell. Why is that? So next. Once you put the time space diagram, so here is the time space diagram of the timing plan. And then you can see the reason. We just click. Yeah, when you click this, you see those arrows, okay, those white arrows, it's indicating departure from the upstream. Okay, upstream green stars and the platoon stars start to depart. And when they arrive the next signal, they all hit red, right? That's why you see a higher percent arrival on red. Okay. However, if we look at the one I just mentioned, Tenaya Way, 30%, you look at the upstream when the green stars, and by the time they get to the downstream, it's actually the platoon arrive when the downstream is already green. So that's why it's reporting lower percent arrival on red. Next. But if you pull out the time space diagram, the timing and the trajectory, then you can clearly see why every vehicle stopped, because we started from upstream, Decatur, the first signal, Decatur Boulevard, okay? By the time we reached Tenaya Way, we were out of the band. So that's the reason we hit red there. So now what I want to indicate is that, you know, most of the time from the trajectory, from the time space diagram, you can pretty much see, you know, why the timing plan is a good one or not so good one, and where you should expect higher percent arrival on red. But just the trajectory without the time space diagram, just the percent arrival on red alone will not give you a full picture of what's happening. Next, please. Next. Just click. Yeah. So here is a short video. You know, for those who has never seen how TransSync works, this is to indicate. You can play the video. You can see we departed from upstream, right? Going through this signal, that's fine. When it's still green, green means look at the blue color. Now we are out of the band. So this vehicle is out of the band. And the next signal is about to turn yellow and it's going to hit red. So I'm really glad to hear that the region is going to adopt TransSync for signal timing project. So this kind of trajectory plus video really gave you a confirmation, you know, what's happening with the signal timing. Next, please. Yeah, this is just to show the timing plan versus real time. Real time, the time space diagram I got from their central system. Next. It's pretty consistent, both. And then this is for the PM peak. So I look at the PM peak and also got the person drive on right. Next. And the trajectories. And you can see this time the trajectories, again, these trajectories also from third-party data sources automatically extracted and plotted, aligned very well, right? It's aligned with the timing plan very well. Next, please. A quick summary. Okay, hopefully I'm still within the time limit. So what I discussed in this presentation, you know, I talked about the two types of ATS-PM, detector fate event-based versus trajectory-based. So both can be automatic. Click. And currently, as I mentioned earlier, it's really there's no widely accepted performance measures are available yet for evaluating corridor level signal timing. Yeah, we do have before after, but before after, as I mentioned, it doesn't give you indication at what level the quality of the timing is. So that is something is really missing in the current practice. Click. I mentioned, percent arrival on red alone or vehicle trajectories alone, is not enough. You really need probably a trajectory, at least with the time-space diagram. Arrival on red will give you another indication to confirm, what's happening with the signal timing. Last. Now, this is the one thing, I do want to emphasize. Because we have been emphasizing performance measures for so many years, never forget our ultimate goal is to eventually improve the system operations. It's not you just get measures and without knowing how to really apply them, how to improve the signal system. Okay, so never forget our ultimate goal as an engineer is to improve. Now, go back to the earlier question I asked you. Do you think once you have ATSPM, you no longer need to do signal timing? The system will automatically give you a solution to improve signal timing. So think about it. I'm not going to say anything now. If you want to further discuss, certainly we can discuss. I can give you my opinions. So that's pretty much my presentation. Hopefully, like I said, even you don't work on signal timing, you get the idea. There is a better way. There's a better way of evaluating signal performance for our projects. So thank you again. Be happy to answer any questions if you have.
Hong, you have a question?
Yes, thank you, Steve. Thank you, Dr. Tian. It's very informative and very good presentation. I have a quick question. You mentioned the trajectory-based the performance index the university proposed. Is that part of your system, the TransSync? Or
Yes.
it's a separate like a subscription-based service?
No, the reporting is part of it, but to extract the trajectories from Weizhou, that is a separate software step I mentioned, right? But once if you have the trajectories, the performance index reporting, that's part of the functions of TransSync.
So then as a user, do we need to subscribe to a separate service to get the vehicle trajectory in order to get the performance index?
But the trajectory, okay, if you want to go there to collect on your own, you don't need anything, right? You just get the trajectories. But if you want to use Weizhou data, yes, you have to purchase Weizhou data, and also you need to use our software, the step, to extract the trajectories from that data.
Okay, so your software doesn't provide those data feed, but as long as we purchase that data feed, then your software can run analysis, provide the report.
That's right. That's right.
Okay, it's a separate. We have to have a separate service subscription to the Weizhou data.
That's right.
Okay, thank you.
You're welcome.
Do we have any other questions? Okay, I don't see any. Thank you so much for your time and for the presentation. With that, we'll go ahead and move on to our next agenda.